So use the reference angle to find the exact trig values. Exact means no decimals. So radical form, fraction form. What is the cosine of 120 degrees? That's the problem. No calculator. So we're going to start by finding the reference angle. But we'll start by sketching the angle. Since we're in degrees, I know we have 0 degrees, we have 90 degrees, we have 180 degrees. 120 degrees is 90, and then plus another 30 gives us the 120, which would be here. So there's the given angle, 120 degrees. The reference angle is the acute angle that touches the x-axis. So this angle is the shortest way to get to the x-axis. So to get the reference, we look at these two values, the x-axis value and our given angle value. We get the larger number, which is the 180 degrees. Subtract the smaller number, 120 degrees. Tells us the reference angle is 60 degrees. So we can use the reference angle in place of the 120 given angle. So instead of finding the cosine of 120, I can find the cosine of 60. So now we just need to know what is the cosine of 60 degrees. And that's where the handy hand trick comes into play. 0, 30 degrees, 45, 60 degrees, 90 degrees. The formula we're using is square root blank over 2. 60 degrees is our angle. Fold in the 60 degree finger. So just like x, y coordinates is x and then y, we have cosine and then sine. So since we want cosine, we want the cosine. There's one finger before our bent end finger, so there's 1 is what we're plugging in. Square root of 1 is 1. So 1 over 2. So it equals 1 over 2. The cosine of 60 degrees is half. We fold in the 60 degree finger. Cosine is on top. There's one finger there. So we plug it into this little formula. Square root of 1 is 1. So 1 over 2 is half. So the cosine of 60 degrees is half. But we want the cosine of 120 degrees. We know it will be half, but we don't know is it positive or is it negative. So we look at where we sketched our original angle, 120 degrees. To plot a point in quadrant 2 from the origin, we have to go left and then up. So when we go left, that's a negative x value and a positive y value. So this is a negative positive, x, y, cosine, sine. So that tells me that cosine is negative in quadrant 2. This angle is in quadrant 2, so its cosine has to be negative. So the cosine of 120 degrees is negative 1/2. Because it's the same size angle as if it was in quadrant 1. And if it was in quadrant 1, then the length of cosine, the x component of the triangle we just made, is 1/2. Let's try another one. Tangent of 7 pi over 6. Find the tangent of 7 pi over 6. So we start by sketching the original angle in radians. If your problem is given to you in radians, you leave it in radians. If it's given to you in degrees, leave it in degrees. 7 pi over 6. Okay, so I know if I like to put pi on here. 7 over 6, so my denominator is 6. So 1 pi would be 6 over 6. And 7 over 6 is just a little bit more than 6 over 6. It's a little extra. So that tells me that it is going to be over here. Just a little bit past the x-axis. 7 over 6 is going to be right here because that's 6 over 6. This is 7 pi over 6. So the reference angle, or the acute angle that the terminal side makes with the x-axis, right here, is the difference. So I'm going to take the bigger number, 7 pi over 6, over 6, and subtract the smaller number, 6 pi over 6. So 6 is the denominator, common denominator. 7 minus 6 is 1, so 1 pi over 6, or just pi over 6. That's my reference angle. So instead of finding tangent of 7 pi over 6, I just need to know what the tangent of pi over 6 is. Pi over 6. That is one of my values that fits on my hand for my hand trick. So over 6, my radian and degrees, 6s and 3s, go opposites together. So like 30 degrees, whenever we were labeling in radians, we counted by pi over 6s. That was 1 pi over 6, goes with 30 degrees. So then 60 degrees goes with pi over 3. So those are back. That's how I remember my pi over 6 and my pi over 3 is they're backwards, the 6 and the, so 30 degrees, pi over 6, 60 degrees, pi over 3. 45 degrees and pi over 4. 4 and 4 go together. That's easy. So I'm looking for pi over 6. That's 30 degrees. I didn't show you guys the tangent on the hand trick the other day, but for tangent, you fold in the finger of your angle, pi over 6, and then flip it over. And on the back of your hand, you're going to square root over square root. Sine over cosine. Since over here, it was cosine and sine on the bottom. So now when you flip it over, now your sine is on the top. And tangent is sine over cosine. 1 finger on top, 3 fingers on bottom. So square root 1 over square root 3. Square root 1 over square root 3. Square root of 1 is 1 over square root of 3. But we can't leave it with a radical in the denominator. I do need you to rationalize the denominator, which is actually a really simple process. It follows the same pattern every time. To rationalize the denominator, you take the radical, the square root 3, move it to the top, and then write the number without the radical on the bottom. Square root 3 over 3. So square root 1 over square root 61. It would be square root 61, move it to the top, over 61. 1 over square root 5, square root 5 over 5. It's just the radical part, move it to the top, write the number without the radical in the bottom, and that's considered proper form. You're not supposed to have a radical in the denominator. Okay, so the tangent of pi over 6 is square root 3 over 3. So now we need to know, so we have the value, square root 3 over 3, but is it positive or negative? So let's look at, go back to our sketch. If we're in quadrant 3, that means we went negative on the x-axis and we went negative on the y-axis. So this was negative comma negative. And tangent is y over x. It's sine over cosine. So if we have negative over negative, that makes it positive. So it's just square root 3 over 3. I have one more example. Let's do the cosine of 11 pi over 3. the same way as we did the others. Cosine of 11 pi over 3. So I'm going to start again by setting this up. Since my denominator's 3, I'm going to come over here and do pi. But if my denominator's 3, I want to make it 3 pi over 3. Well, I have 11 pi over 3, so that's not enough. So then if I went all the way around the circle, that would be 2 pi. But if the denominator is 3, that would be 6 pi over 3. That's all the way around the circle. But that's still not enough. So that tells me I go all the way around the circle, but I'm not finished yet. I still have more in my given fraction. So I'm going to go 11 pi over 3. Subtract one time around the circle, which is 6 pi over 3. And that tells me 5 pi over 3. I still have 5 pi over 3 left to sketch. So from going one time around, and then I have to go to 5 over 3. Well, 5 over 3 is almost 2. If that was 6 over 3, it would be closing the circle a second time. So it's just stopping shy of that. So we're going to come all the way over here to quadrant 4 again. And that is 11 pi over 3. But I also want to write my 5 pi over 3 over here, because it's one time around plus 5 pi over 3. So then to get the reference angle here, I still want to get that acute angle that the terminal side makes with the x-axis. So that's the same as this. And to find that value, I want to use this 5 pi over 3. Okay? So I want to do 6. The larger of these two values is the 6 over 3. 6 pi over 3 minus 5 pi over 3 gives me 1 pi over 3. So the reference angle is pi over 3. So then the cosine of the reference angle is what I'm going to use my hand trick for. Pi over 3. Pi over 3 goes with 60 degrees. Fold that one in. Cosine, so remember if you do it this way, it's x, y. The same way you write your xy coordinates is cosine sine. So cosine is up here. There's one finger above my folded in finger. So one finger goes into my formula, square root 1 over 2. Square root of 1 is 1. So this is 1/2. So I know this is also 1/2. I just have to figure out now, is that a positive half or negative half? To figure out if it's positive or negative, I'm going to come back to my sketch. Since I'm in quadrant 4, to plot a point in quadrant 4, I have to go to the right and down. So I know that is a positive x and a negative y. So it's positive cosine, negative sine. This is cosine. Cosine is positive. So that's it. I'm done. It is positive 1/2. As you do these problems, it will make more sense and be easier. Is this something that definitely takes practice to fully grasp? So there you are.